The next thing I want to talk about is this idea of creating a debug VI. And let me just show you what I'm talking about. So I'll go back to my framework. The basic idea here is because of this shift register, because of this fact that all that data is being stored, kept, and reused. So I just jump to the tell-off case because that's the one we're actually going to run. We can create a VI that sits right here that allows us to monitor some important information. All right, we talked a little bit before, the point came up before that we were seeing some flakiness in the controller, especially in vision while doing probing. So here's a way to make sure that you don't have 5 different VIs open with probes lined up all over the place. Here's, if you've got some key information that you want to look at, then here's a nice simple way to do it. So what I'm going to do is I'm going to create a new SubVI, and I'm going to show you a shortcut how to do it. I'm going to go to my structures palette, create a flat sequence right here. I'm going to break my wire, and I'm going to wire right through it. The sequence is going to be deleted, but it's just a convenience tool so that I can use this method to create a SubVI. That method is to go to the Edit menu and say, Create SubVI. Right. There's 2 ways to create SubVIs. One is using this menu item by selecting existing code. And the second is to create a VI from scratch and then link up all the inputs and outputs. And I'll show you both really quickly. So I've just created a SubVI. If I open it up, well, look at what I've got on my front panel. I've got 2 copies of this robot data. One is a control and one is an indicator. And if I look at the code, well, there's my sequence structure. The only reason I put that sequence structure there is it's a nice, convenient way to allow me to have something to select for that menu item. So the structure is going to go away. And I'll give these things their proper names. Robot data in, robot data out. What I really want to do here is this is going to be not a proper dashboard, not the dashboard for competition, but a debugging dashboard. This is where I'm going to pull out just the data I want to peek at for testing purposes. So I'm going to put down a cluster, unbundle by name, and actually I'm going to connect my input to my output because I don't want to change anything. I'm just monitoring. I'm going to connect this guy up. So now I have access to all of that information. Everything that's in my type def, I can pull out and display. So this is where we can actually take advantage of the fact that we can change this type def and put whatever we want in it so that we can display what we really need to see. So I'm going to do that right now. So I'm going to right click on my type def, choose open type def, I'm going to put some stuff in here. I'm going to create a numeric indicator, call it right encoder reading. Make a duplicate of that, call it left encoder reading. And put those guys inside here. And I'm also going to do that shut-off time thing that we talked about a second ago. So I'm going to store numeric timestamp control, which is shut-off time. I'm going to save and close this type def. And of course, because it's a type def, that's propagated everywhere. So the first thing I want to do, I'm going to put this VI aside, but before I do, I'm just going to save it. And this is probably a reasonable time to do a little bit of cleanup. So I'm going to create a new directory and call it SubVIs. Just a nice way to keep track of where all the SubVIs you're creating are going. And I'm going to just call this the debug dashboard. Okay. Close that. And go to my tell-off here. So what I want to do now is I want to take these 2 encoder readings and put them in to that type def. So what do I need in order to do that? It's a cluster, so I need to bundle. Exactly. So I bundle by name. An important thing to remember about the bundle by name is that the middle terminal must be wired. I'm going to stretch this out again. The purpose of the middle terminal is to tell the bundle by name what kind of data it has. and also the values inside that cluster. So because I've wired that middle terminal, it knows all the information. So I can choose my right encoder reading. Actually, I'll start with the left encoder reading, my right encoder reading, and I'll just put that data right in. So these indicators I created a minute ago. Well, now they've been obscured by the type def because of Perdu, but I'll just move them to the side. These indicators I created before. They're only visible when the tele-op VI is open. Right? We want to see that data somewhere else. So we're going to put it into our type def. And that was the whole purpose of this. And I'm going to break this wire and connect it up. So what is this bundle by name doing? It's only replacing these two values. Everything else is staying exactly the same. And while I'm here, I'm going to just make a modification to actually use an unbundle by name, pull out the shutoff time. I'm going to go to my timing palette, pull out the current date time, and I'm going to just do some logic. If my current time is greater than my shutoff time, then I'm going to disable my drive. So this actually we don't want to be in the true case, right? If the current time is greater than my shutoff time, this should actually be in the false case. So I right click, make this case false. And again, if we're in the shutoff case, if the current time is greater than the shutoff time, that should be a 0, and that should be a 0. And I've made a mess of my block diagram. I'm going to do some of those rerouting techniques. And rewire this guy. Okay, he comes around like that. So, back to the main robot main, and then back to our debug dashboard. So what we want to do is we want to pull out the right encoder and left encoder reading. Since this is a dashboard, we can create any kind of numeric indicator we want. So let's use a meter. Maybe we'll go 0, 500. Maybe we'll even go plus or minus 500. Just hook those two up. And give them right names. So right. Okay. So we'll just leave this open. And before I go any further, I'm just going to show you how to edit the icon. If you have the VI open, you right click on it, choose Edit Icon, and you can type whatever you want to. There's a shortcut I love, because I'm not one for really fancy icons, which is to change the background color, and then double click on the filled rectangle, and click on the A tool, double click to choose the fonts. Windows has got a font called Small Fonts. Very helpful. Small font size 8, perfect. And I call this my dash border. And if you don't click off, you can actually use the arrow keys to move that text around. So for those of you who've done a little bit of icon editing, that might save you a couple seconds. Or for those of you who really like making pretty icons, well, good for you. I'm not one. And the last thing I want to show is, if you go to the front panel, I mentioned how you have to wire up these inputs and outputs so that the calling program knows how to do the inputs and the outputs of the SubVI. If you right click and say Show Connector, you see that I've got two pink blocks. If I click on the left one, we see that if I use the wiring tool, click on the left one, we see that that's linked to the robot data in.